Welcome, students, to Lecture 4, Subpart TF-IDF, basically term frequency, inverse document frequency. Now, look, this one is slightly technical, so I wanted to go over the technicality of what this metric is. First of all, this metric falls under a concept we call surprise words or surprise factors in text analytics. Right, so it's term frequency inverse document frequency. What does this whole thing mean, right? So it's a stat that helps us kind of identify a word that is important in a certain document within a certain collection. It's common in text mining and obviously information retrieval. It's the first really step when we're trying to identify something important within a document or corpus of documents, and it's all about the finding a word that isn't very common and isn't a stop word as well, right? So we talked about stop words before. There are common words and all this stuff, et cetera, et cetera. They tend to be obvious in any subset data. But another set of words that are obvious in any set of data is what we call domain-specific words. Domain-specific words, I'll give you an example in a second, but essentially in the type of data you're analyzing, there's certain words outside of your stop words that show up over and over and over again. This might not be the case in some of the documents we're working with, especially when we're dealing with some of the social media stuff, but it's inherent in a lot of documents in a professional setting. And I have a little example for you guys later on the slide for you guys to check out. What we want to do is we want to identify words that obviously aren't our stop words and that obviously aren't our domain specific words. These are words that all of a sudden come out of nowhere in a particular document, right? It's not in the other documents, or it might be less in other documents, but all of a sudden it explodes in a certain part of the document. Why is that happening? That is a word, again, goes back to the concept of called surprise factor of a word, and we want to know why that's essentially happening. So our first step one is actually to identify these words. I keep using the term document, and we'll use the term document throughout the class. We have to understand when we say document, this is a loose term, and basically another way we can describe it is slicing up the data. It's basically how do we subcategorize the data of the corpus of data that we're analyzing. If you look at my Wall Street Bets data set, that is, one way we can divide it, each posting can be a separate document. I think I have 998 postings for my Wall Street Bets, so each individual posting could be considered a separate document. But that doesn't need to be the case. We can also group those postings by days, by a certain day. So all the postings in a certain day could be considered one document, or in a certain week, month, year, et cetera, et cetera. Also, maybe if there's certain postings from certain users, each particular user's postings can be considered a separate document. So the way we define document in the corpus of our data can be done through multiple features of the data. It really depends on what we're trying to do. It makes most sense right now, on the surface for me when I'm going through Wall Street Bets, is to basically use each posting as an individual document, right? But again, that's not really necessary for the type of analysis you're doing. Now, here's a simple example in the domain of medicine. Suppose we have a collection of documents, and here we have, it's very easy, each document will be the individual document, so it'll be 3 documents. And related to cardiology. Here are 3 samples. The patient was diagnosed with myocardial infarction. I don't know if that's supposed to be infraction or infarction, and prescribed aspirin. Aspirin is commonly used to treat heart conditions like angina and myocardial. Again, I think that's infraction, but let's go with it. Infarction. Document 3, the cardiologist recommended an ECG to assess cardiac function. All right? 3 postings, right? And those 3 postings, we will define each posting as a separate document, right, out of the whole corpus of data. Now, to calculate our TF-IDF, right, we want to basically, the whole point of calculating the TF-IDF in this set of documents, if you will, is to highlight medical terms that are obviously specific to cardiology, but not in general language. Now, in this example, we have three, if you look back again, we have three documents. They're all dealing with cardiology. Let's say we had 100 documents, but only three documents dealt with cardiology, right? Any term dealing with cardiology we would basically want to be highlighted that, hey, this word, or let's say cardiology, it's not in any of the other documents, medical documents, but for some reason these three documents, it's all over the place. That's basically the idea of a TF-IDF. If we just use these three documents and calculate our TF-IDF as a language, as an example, this is one way to kind of understand what we're trying to do here. Oh, cool. We have the terms and why is domain specific. Myocardial infarction, again, just doesn't seem right. Specific to hard cats, rare and general text. So here are the particular terms in the space of cardiology, the domain of cardiology. Now, these words would have a higher TF-IDF score in a general corpus because of the fact that they're rare they're rare elsewhere, but they're high in cardiology. Let's do an example. But let's just use these three. Let's just use those three documents as an example for us. Now, the steps in calculating the TF-IDF is essentially 4 steps. First, we want to define what do we mean by documents, right? Slice the data up based on what you define the documents to be. Again, in our example right here, it's simply going to be 1, 2, 3. Done, easy. In my Wall Street Bets data set, it's going to be each posting, each row of data essentially is going to be a separate domain. Easy. Some of you guys have time series you're dealing with. Maybe a scope of a time frame might be a separate document for you, right? So it varies. Step 2, obviously, tokenize the words. We've been doing this a lot. We'll use Spacy this time to do it. Step 3 is to calculate our IDF, or inverse document frequency, for all the words. And then step 4 is calculate the term frequency for all the words and the subset and each documentation and document combination. So we want to calculate the term frequency for each document, right? So it's not total for the whole list of corpus. We want to slice it up by each document, our term frequency. All right, now here, selecting the docs. This is pretty straightforward. Doc 1, Doc 2, Doc 3. Boom. Step 2, we tokenize the words. Again, pretty straightforward. I just take the words, break it up. Remember, the most basic way is to do by spaces and punctuation. Notice that punctuation is there. We'll just leave it there. The period is there. So we broke up it into its words, as we've done before. And now, step 3, now let's get into it. First, let's calculate our IDF, our inverse document frequency, right? It measures how important a term is across all documents, and rare terms get higher scores, okay? Rare terms get higher scores, and that is a function of the definition. As you remember, we are taking a log. First of all, our calculation is n as our numerator. What is essentially n? N is the number of all our documents, the number of documents. So again, in this example, it would be 3. We have 3 documents, all right? I believe in my Wall Street Bets, it's 998 rows. Now, our denominator, df parenthesis t, this is essentially the number of documents that contain that term, that word. That is essentially what the IDF is. It is a fraction of where the numerator is the total amount of documents you have, and the denominator, and this is unique for each word. For each word has its own IDF, where the numerators are all the same. Done. In this case, it's all going to be 3. But the denominator is basically going to be how many documents did that word show up in. It does not matter if the word showed up once. It does not matter if the word showed up 50 times. All that matters is how many documents did that word show up in. That's your denominator. Let's do an example. Here are our words all broken up. Again, our tokens. And let's just do myocardial. So again, our numerator is 3. Our denominator will be, well, myocardial shows up here. Myocardial shows up here. And that's it. So out of the 2 of the 3 documents, we have myocardial. So in the denominator, bam, you're going to have 2. We take the log. Because remember, what does log essentially do? Log pretty much reduces our range of values. That's essentially what it's doing. It reduces our range of values. We don't want a crazy range of values, especially when we have a large, like many, many more docs. And because of the fact that we're dealing with stats and numbers where you're going to have like 0, 0, 0, 0.1, and then all of a sudden a big number, we need to reduce the range of values we have, and that's what we take to log. So in this case, my IDF score for myocardial is 0.405. Very straightforward. All right. So that's essentially the IDF. Each word, what we'll do is we'll take a list of all, and we've done this before. We'll take all our list of unique words and we will calculate the IDF for each word. And then we're going to use this a little bit later with our TF. Now, here, if you look, I pretty much counted up for each word, how many times it shows up. Myocardial, like I said before, it shows up in 2 documents. We could have got rid of our stop words. Shows up in 2 documents. Patient shows up in 1 document. Was in 1 document, etc., etc., etc. Right? And here when we calculate the inverse document frequency for all the words, again, notice the numerator is going to be the same for each word, obviously, because for every word there's a total amount of documents. But each word now, the denominator is going to change based on how many documents the word shows up in. All right? Doesn't matter if it shows up 5 times in a document or once in a document. We just want to know how many of the documents the word just shows up. All right. Now, once we have our IDF, we now are going to calculate our term frequency. The term frequency is slightly more complex in the sense that we want to calculate how many times the word, let's say myocardial again, appears in a particular document, right? Over, and it's a fraction number again, over the total number of terms in that document. This is a calculation that happens for each word in a document, meaning that if we have one word, let's take myocardial again, because myocardial shows up in, if I show you here, shows up in 2 different documents, right? We're going to have a TF score that is different for document 1 than it is for document 2. So the myocardial total frequency score in document 1 will be different than the myocardial total frequency score or TF score in document 2, because this must be done within each document, the total frequency. All right, and again, I have the example right here. So for myocardial in document 1, it's going to be basically, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Again, it's horrible that's there, but let's go with it. So myocardial, right, the number of times the term T appears in document 1 divided by the total number of terms in document 1 is going to be 1 over 11. Right? If we did it again for document 2, it's going to be basically myocardial shows up 1 out of a total words of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So in document 2, the total frequency for myocardial would be 1 out of 14. You see, each word will have a different term frequency for each document, Right? And now we put it all together. So here's an example. I showed up these. In fact, what I did was I took the ones with the highest TF-IDF score, and it turned out in our example, and again, sorry for that, these words right here had the highest TF-IDF score. The frequency, again, this is a silly example, but roll with it. This is their IDF scores that we calculated from before. All right, and then the frequency times the IDF gave me my TF-IDF, and then when you sort for it and you find the ones with the TF-IDF, the idea here is which TF-IDF is the largest, what word is it, and which document is it? Because now what this does is it basically tells us, hey, this word was very important to this document out of the whole sets of documents. You might want to check out why that's the case, right? Why do we have, it's an interesting word, and it's important in a certain document or certain set of documents. And why is the case? Now, this is something that jumps up at us so that we can help, and again, this is text mining, people. We can start analyzing maybe something special happened within the corpus of our documents. So again, this should signal something. And now, people, let's do this in Python. All right, let's take our same example right here. And I want to take the same example and do it in Python, because if you could do this in Python, We can do any of our data sets in Python. All right, so first what I'm going to do is I'm going to create a table with these texts right there. These texts right there. And from there, I'm just going to roll with it. So I'm going to cheat because I already have, I think, pasted somewhere. But first things first, let me zoom in a little bit so you guys can see this. And I'll post this code along with the example. So we'll call this the lecture 4 example. Lecture 4 TF-IDF. I'll call it TF-IDF. So that everybody has it. All right, so from here. Now look, we already know we're going to import a load of stuff here. Let's do it all here. To be more disciplined, have all our imports in the top. I'm not going to really use regex, but you know, I'll have it here for now, right? Why not? Because this time I actually want to use Spacy. So guys, when we tokenize it, if you guys remember, we've tokenized it using regex before. I'm going to go ahead and use Spacy this time to tokenize it. Import my counter. I'm going to make a word cloud because this is something I want you guys to load up. Under assignments, I'll set that up for you guys. And on your data set, by the way, of course. Import pyplot. This is to help us save it as well as show it. And I'm abandoning Plotly because it just is too complex to do it on your machines. Plotly is great for an HTML because all the browsers take care of all the packages. It's just too complex on your machines. So we're going to just use Seaborn instead. Seaborn is one of the big 3 graphing tools for Python. But when it comes to visual analytics, there's another one. I think it's called C-Line ggplot. And it mirrors like the ggplot graphing tool in R. Maybe a little bit later, if we have time, I'll show you guys. So these are all the imports I want to do. Now, to use, remember, I want to tokenize my words. So let's set that up right here. I want to go ahead and also use Spacy to do my tokenization. To do this, I need to download something weird. Bear with me, this is really weird. You have to run this command right here. Right, you have to run this command right here. Notice you have to have the exclamation point before it. And Spider does not like this. So what you do is you run this. It's taking a while. Okay, cool. And you notice it says now you can download the package via Spacy load en core web sm. When we used NLTK, we downloaded this, something equivalent to this, some English kind of package of words. And we're doing the same thing for Spacy. As soon as you do this, go ahead and just, you never have to do this again. You can get rid of it. I'm going to comment this out, right, because Spider doesn't like it, but I will leave it there just so you guys have it. And I will go ahead now and load up Spacy. And again, it's like it's sort of like how we download a dictionary of words, guys. I'm doing this because this dictionary of words I'm going to use is, I mean, like when we're downloading our stop words, I'm going to use this to break up to tokenize my words, right? And later on, we can talk about how to customize Spacy, how Spacy is doing it. I showed you guys how to do it with regular expressions. Again, there's multiple ways to do this. But we have Spacy. We're going to start using Spacy. Might as well start using it to do this as well. All right, now, from here, let's create our table, people. And again, it's right here. Our documents right here. I think, let me see if I can copy and paste it. If not, I'm just going to cheat. You know, that's what I'm about, people. All right, okay, fine. So you just copy it from here. So I'm going to make one giant list. So this is the first one, comma. I'll take the second one. All right, notice I scroll all the way over. this is quite annoying. Can't even see. All right. Now I'll do another comma and add, paste in the final one. And I got it. Oh, see, it actually just, okay. So here, let's do this. All right, there we go. It kind of just wrapped the underside, yeah. Oh, oh, oh. Cardiologists recommend an ECG to assess cardiac function. All right, somehow accidentally I got this. I just want to make sure that I have everything right. The patient was diagnosed with myocardial infarction and prescribed aspirin. All right, let me put a period there. It's missing its period. Aspirin is commonly used to treat heart conditions like angina. Oh, this is what we're missing right here. I'll take that. All right, and finally, the cardiologist recommended an ECG to assess cardiac function. All right, cool. So I have this. This is my list, and I'm going to use my list to create a table. I'll call this MD data frame, MDDF. I don't think you've seen me guys do this before. Some of my new students, so my non-Python students. So I'm basically taking a list of words here, and I'm going to say this list of words will now become a column in this new table I'm creating called MDDF. When I run this right here, go to MDF right here, and you'll notice, boom, I have this simple little table. Its default index is 0, 1, 2, and with the words and the sentences in the dot column. All right, done. Now the next step, obviously, is, you guys remember this. Now we could go ahead and just break this up, but remember, caps and lowercase, it matters. To make our life easier, we're just going to make everything lowercase. We don't want words repeating. So I'll call this text L, just to keep it consistent to what we've been doing. It's going to be the doc take column. I'm using the str package on the dot column, and I'm saying make it all lower. Boom. All right, there we are, made everything lowercase. And from here, people, let's go ahead and make our tokens using Spacy. I will use the apply lambda trick because we have to apply a function to it. The function I'm going to apply to it is literally just going to be, see this NLP thing we download over here in line 20 from Spacy? Just going to use that. Remember, I will become each row right here. I will become this row. Oh, sorry, the lowercase one. I will become this row. I will become that row. And then this one. And so each time it becomes that row, the function NLP will be applied to it, break it up, and put the new list of words under token. Now, Spacy's cool and all. The problem with Spacy is it creates objects. So we have to sometimes take the objects it creates and put them back into lists when we want to do other things. You'll see what I'm talking about in a second. But here I go run this. And now if I do mdf.token, boom, see that? We have it. We have our token words. But like I said before, notice how this is before when we used to do it, we used to have these brackets for lists. These are parentheses. What's happening here? These tokens, if you want to call them, when we use Spacy to do the breaking up, they're objects. So they're essentially what they're called. They're called document objects. This is the thing that's within the world of Spacy. The reason they do this is because each one of these document objects has so many features that we can use later on, and you guys will see how we do that. We obviously are just going to go ahead and convert this back into a list to make our life easy in a moment, right? But for now, this is essentially, we have our tokens. We use Spacy to do it. A little later on, we'll explore the more advanced features in here. But for now, again, we just want to go from here, and we want to convert these objects into a simple list because we want to use a list to do what we again to calculate our IDF, TF-IDF. So I'm going to create another column now. I'll call this token L for list. And I'm using token this time. This might get a little crazy for some of you. All right. Now what I want to do now is I want to loop through every value here. Let's take one row, right? So remember, like lambda I will become this row, row 0. Sorry. It'll take on this, it'll take on this, and it'll take on that. When I, for example, take on the first row right here, I want to loop through, I want to go through every word, and I want to basically take the text out of that object. So I want to just have the patient was blah, 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 right? So I'm going to actually run a for loop within each row, believe it or not, and make a list out of it. So here, I'm going to have brackets for that I want the output to be a list. And this list is going to be generated using for every token, or I mean, I don't want to confuse you guys. Let's say for every token object in I, right? So token object will literally become this word, then that word, then this word, then that word, then this word, right? For each one of these, I want to, now before the for, I want to basically extract the text from every object. So this part lambda I is going to iterate through every row, right? When it iterates through every row, this for loop is going to kick in to go through each element within each row. So token object is going to go the token object is going to go from object to object right here, and then literally say grab the text and stick it in, and what these brackets over here means is going to stick it in this list. It's going to keep just appending into this list again, just like we created a list up here, guys. It's going to use a for loop to create that list over there. So when I run this now, and now you look at MDF token L, boom. Notice you don't have the parentheses like we do up here now. We have the square brackets again. It's now a simple list again for us to use. Now again, we have both because even with my Wall Street bets, I will save both because I want to be able to use the Spacy features going forward. But for now, we have both. Let's go ahead and now do our next step, which is going to be calculating. We want to start calculating let's start with always the IDF. Usually, you could do any way you want, essentially. I will start off with the IDF because it's kind of easier to do. So what I need first is I need another, if you look at my rows right here, and this is kind of easy to do, right? We talked about this before, where I wanted to count all the words, and sometimes I didn't count all the words. In this case now, since we're calculating the TF-IDF and we're doing it properly per document, right? My IDF, I need to now basically create another column from each one of these words where I simply just take the unique words. In this case, this is easy because I think each one of these words in this example, it's a very simple example, are unique. But let's say, for example, we had certain words repeating over and over again. I just want to somehow get you the unique set of words. And the reason I want to do this is because I want to be able to count how many times a word shows up in each document. In this case, each row, right? Whenever we're doing this with pandas, each document, no matter how we define it or slice it up, will be defined by each row. So the reason I want to take every unique value, because I want to, when I do explode and count, like for example, let me just show you, if I could show you in Excel real quick what I'm talking about here. Oops. Right. So let's say I have a list of words. Here's my column, token, whatever you want to call it. Oh my God, you can't even see that. Hold on. Let's make this bigger. Boom, right? And we have a list of words. Let's say we have apple, apple, mango, apple, right? And I'll do another one. Apple, apple, orange, cherry. And let's do a third one. Grape, plum, orange, cherry. All right, this is fine. Now let's say I want to count. I have 3 documents here. Each row is a document. Let's say I want to count how many documents have the word apple. Well, that's going to be basically 2. The reason I'm saying is that I want to create another column that's going to have just the unique values in each list and not them all is because if you remember how when we do explode to list, how it works. Essentially what explode to list is going to do is it's going to take this list, concatenate it to this list, concatenate it to this list, and give me a big column, and apple will be shown up 4 times, or no, in this case, 5 times in that column, right? Which is going to throw it by number. If I simply just take the unique value and then do the explode, well, then the number of times apple shows up in that column will be basically the number of documents where apple shows up. So here is an example. If I do take the unique right here, this will be apple. Apple, mango. This will be apple, orange, cherry. This will be, oh, these are all unique, so I'll just take that. Boom, done. Right? Now, here in this column in B, if I simply took this column right here, the token one, we'll call this token U for unique. If I simply exploded this one, like I said before, Apple would have showed up 5 times. If I explode this one now, Apple will only show up 2 times. That 2 now will accurately represent how many documents Apple actually shows up in. So this is why in my next step right here, all right, I have my token list here. I want to create another column where I take the unique values. And we've done this before. There's a very, very easy way to do this. Sorry, let me zoom in a little bit. I don't know how big your screens are. And we'll call this, again, token U for unique. Token L, dot apply. Yeah, this lambda thing's all over the place. And this time, what I'm going to do is, I'm just going to use my list and set argument all over again. Remember when we convert a list to a set, it automatically takes away all the repeating values. And then we use list again, it converts it back into a list. So if I do this right here, and we don't have a really good example for this because I think in this example, all the words are unique anyway. But here, each row will be converted to a set. When that happens, every unique word is going to be gone. Then I take that set, convert it back into a list, and then it's a normal list for us to work again. And then here, I can do this. And I really don't think it's going to make a difference because they're all unique anyway. But again, in your actual documents, you'll probably see the difference, right? So I now have my unique tokens. Okay, now from here, what's the next step? Well, like we said before, let's create a whole list around this. I'm going to go now explode token U, count up all that count them all up. So I'll simply do we'll call it, I'm sorry, I don't even know what to count it. Let's call it for lack of an imagination, I'll just call it MDDF underscore list. And again, this is going to be just MDDF dot token U dot explode dot, make it into a to list. Boom. And now we have our list right here. All right. We took basically all the columns here and concatenated into one big giant list. Right? Boom, 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 boom. All right. Now from here, we have that list. We're now obviously going to count it using our counter. Call this counter. Count this right here. And now I now have successfully counted how many times each word shows up in each document. Again, totally apologize for that period. Period shows up 3 times. Aspirin shows up in 2 documents. Myocardial shows up in 2 documents, and so on and so forth. All right, now from here, we want to go ahead and do our math. So we're going to go ahead and take this, as we've done before. Remember, this is like a dictionary object. We're going to take this dictionary object and convert it into another table. I'll call this new table, oh God, I'll call it MDF. Again, I apologize. This time I'll just use 1D. And I'm going to make this table from a dictionary, which is going to be obviously this right here. Oriented according to the index, and the columns is going to be count. Boom. All right, we have our table, and notice the words became the indexes here, indexes. And we essentially have one column called count. All right. We can mess with this. We can adjust this. We can slide the indexes over into a new column. We have a lot of flexibility in how we want to work this. All right. From here, though, I have my count. The next part is I simply just want to calculate my IDF now. Remember from our formula here, just to jog your memory. Right, it's basically this formula right here. Total number of words divided by how many times each document, total number of documents, sorry, divided by, the numerator is the document, divided by how many documents the word shows up in. So my example right here, I'm going to use NumPy. Remember, any fancy math, we use the NumPy package to do it. We're going to have our numerator 3 divided by the count column. Straightforward. So now we're going to simply have a new column called IDF. Ta-da! We have everything. All right, and now we have our IDF ready to go. Okay, now from here, I need to now calculate my total frequency. So now we're going to do our TF. And remember, this is now going to be in by each document. We're doing this. We're going to be doing this by each document. So let's go back to our MDDF table right here. We're going back to our MDDF table right here. And now what I want to do is I want to create a, let's see, a list. Well, we'll go ahead and create a list basically. What we want to do is we want to, if you remember, this might get a little confusing for you. Here in the counter, when we use counter, right, we created a dictionary, and then we can iterate through the dictionary and get the value. So let me just show you an example. We have MDDFC here, all right? So if I simply did for, I can iterate through that dictionary. I can simply say for, and I can word, comma, count, right? Because remember, MDDFC is a dictionary. And if you remember, it's a dictionary with the key and the value, the key and the value and the key and the value, right? So if I can iterate through this, and print out those words. So if I can go for word and count in, so this is going to iterate through the words. This will iterate through the second part. This will iterate, obviously, word will become the first part of the combination partnership. The count will become the second part. And I'm going to iterate through MDFC dot items. All right, items will give you that unique pair. If I just ran this part right here, you can see it for yourself. Items. You can see how you get this object right here, right? In these like parentheses, unique pairings. We can iterate through this in those two parts. Right here, I can simply just do now. I'm just going to do print word, print count, just so you guys can see it. So when I do this, boom, right, as you can see, I iterated through all of it, printing the word, the count, the word, the count, the word count, etc., etc. Now, why am I showing you that I can iterate through this for loop? Like I said before, here, right, when we're doing the total myocardial for document 1, here for each document, I need to go through each one of these words, and I need to count up how many times each word shows up. Hence, I'm going to use counter. Hence, I want to use counter on each row. I'm going to use a counter on each row, but when I use counter on each row, I want to be able to get the word and the count and divide by the total number of words. So I want to do this operation row by row. Obviously, I'm going to be using lambda apply, but it's going to get a little weird. So I want to show you this example right here. All right, so now let's go ahead and go back to MDDF, the MDDF table. And in the MDDF table, I'm going to create a new column called TF list, the total frequency list. All right. I'm going to use MDDF.token. I will not use, I'm going to go back to using the token list again, because remember, this is the unique words. Now I need token list because I need to now know, whereas when we're calculating the IDF, we want the unique words. When we calculate the TF, we want the words to show up. We want to know the proper count of how many times the word showed up in each document. So now I'm going back to token L. And here now I'll do apply lambda I. Again, I could be any variable. I just keep using I, just force of habit. Okay, now it's going to get a little bit weird, people. All right, now we're going to get a little bit weird right here. So let's set up a for loop like we did before. I'm going to set up my for loop. Now, my result, just like before when we did a for loop up here, where was it? Right here, in line 27. I wanted the result as a list, so I put my for loop in a square bracket for a list. I'm going to do the same thing again because I want my result in a list. Done. I'm going to do my for loop. I'm going to say for word, comma, count in. Now, here is the weird thing. Whereas before, I ran counter, created this counter object as essentially a dictionary, and then I looped through that dictionary. Instead of doing that, and I could have done this in 2 steps. I'm going to go ahead and do it in 1 step. Now, in hindsight, I probably think I should do it in 2 steps. So it might be easier for you guys, but whatever. We'll roll with it. I'm going to go do this in 1 step. I'm going to go ahead and call counter on I. Right? So this is going to be like creating that object right there. And I'm going to directly use that object in the same for loop. I'm going to say dot items directly on it. Bam. See, where I did this here, I did 2 steps. I created the object, and then I looped through the object right here. Here, I'm just going to do it in 1 shot. I'm going to call counter on each row, and I'm going to loop through the items. And now I'll have word and count. All right? Now, I don't just want, whereas up in here in line 27, we were just simply taking the text of each token object and putting that into a list. Here now, I'll be taking not 1, but I'll be taking 2 items and putting that into a list, right? And to do that, I need to, remember, this goes before the for. Anything before the for is basically what's going to be stored into the list. So I don't want to just choose word. I don't want to choose count. I want to choose both of them. So to do that, I need to basically say, all right, I'll put an extra bracket there, and I'll choose count. So basically what's going to happen is, instead of just one word, it's going to be a list within a list. I'm saving a list within a list of these combinations of word and count. Now, we're not done. Remember, this count right here is going to be each unique word. If I show you an example, this count right here will give me the count of each word in the sentence. Now, again, we don't have a good example because each one of these are unique. But let's say, for example, myocardial showed up twice in document 1. So myocardial would have the number 2 with it, right? But the term frequency, if you will, is the number of times myocardial shows up in document 1 divided by the total number of words in document 1, all right? So we're not done here just yet. I want to take the additional step and divide this amount. This word shows up this many times in each row, in each document. But remember, I want to divide this by the total amount of words in this document, or in this row, if you will. And to do that, I'm simply going to just take, remember, I represents my list of words for each row. So I'm going to use a function called len for length. And what len does is, if you guessed it, it pretty much gives you the length of each list, right? So if I do a silly example right here, my pizza is yummy. Save this as P for pizza, right? And so I have this list called P, and if I run lnp on it, it gives me the answer 4, because the length of this list is 4. So here, the length of I is going to give you the amount of words in each row, in each document. Count will be the amount of times this particular word shows up in that document, and boom, we got what we're calculating right here. Bam. So I go ahead and run this. Let me comment this example out for you. And now if we do mddf.tf list, boom, look at that. All right, what do we got here? What do we got? We got, if you can see here, this example right here, you got a list, shows up this many times, patient. So you see how, I don't know how clear it is, but in your example, in your Python console, you should be able to see how there's like lists within lists. You got this list right there. You got one for prescribed right here, 0.00909, blah, 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 right? So now we got our term frequency, and we're ready to rock. So we got our term frequency, we got our inverse document frequency, we're now ready to bring it together. All right, this slightly complex in the sense that here I have my MDF table. My MDF table has my inverse document frequency, and my MDF table and the TF list I have my term frequency. All right, now here in my TF list, let's go ahead and extrapolate this out into another table, right? Because if you look at my MDF list right here, we have all these values right here. We want to basically take them out, and we want to make this into another table. All these values want to have one nice little column with the words and the TF score for each document, and we want to have a nice little table. So before we can jump into MDF, let's go ahead and clean this up. And obviously I'm going to use my explode. And I'll call this table TF explode, for lack of a better word, total term frequency explode. And now I'm not going to do 2 lists. I'm just going to explode this, guys. And you'll see this why I'm going to do this in a sec. All right. Oops. Let me run this. Check this out. Why did I do this? I did this because I didn't do it as a to list right now. And the reason I did this is because I want to be able to preserve, see these indexes right here, 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, 2, 2. I have my results, but I want to preserve where the results came from. Because, for example, myocardial right here for document 1, it shows up as 0, is 0.009. But if I come here to myocardial from document 2, shows up as 1, it's going to be 0.07. I need to preserve which each document came from. And that's why I just did explode, but I didn't do to list. Because from here, I'm going to take the TF explode, and I'm going to load this into another table. All right, so I'll create a new table called TF. And this will be, I'll make this into a data frame using my TF explode right here. And now I'll use toList and this portion right here. And now I'll use the index. I'll save it. Did I want to save it? Yeah, I'll save it. TF explode dot index. And now the index will be preserved as the index for this new table. So when I run this, TF, check it out. All right. You'll notice now I have, it basically took these list of words and made them into each column. And I have the initial documents preserved right here, where they came from. And again, they're preserved the indexes. I can go ahead and slide them over so that I have it in a way to use it. And again, that's fine how I want to use it. All right. Notice that the column name is 0 and 1. So I want to change this. Let's go ahead and the way we change the column name is we simply just do dot columns equals, and we can simply just say make the first 0 is going to be word, and the 1 is my TF, term frequency. Done. Oh, the name of the table is TF. Okay, let's just call it frequency. I don't want to. And here we have that. All right, now we are ready to rock. Okay, from here now, if you notice, I have my original, my MDF-IDF table here. Here are TF.columns. Notice that we have the word is going to be repeating here. Because again, we have, let's myocardial. Myocardial will repeat in document 1, and myocardial will repeat in document 2. Whereas in the MDF table, where we have our IDF table, I'll just run the whole thing. Each word is there just once, right? Nature of the beast. Remember, it's all unique. We just need to know how many times each word shows up in each document using our formula. The number, n divided by the number of times it shows on each document, and we take the log of that. So essentially what we want to do is we want to take these values right here, and we want to copy them back into our TF table where they properly go. Essentially by the word. Now there's a little trick here. I can show you guys how to do this. What we can do is we can go ahead and use our MDF table, and I can convert 2 of the values into a dictionary and then use that dictionary to update my TF table. Right? So let me show you what I'm talking about. So I'm going to go here and create a dictionary called m_dictionary, and this will be using the dictionary function and another weird function called zip. Again, I don't know why I need zip, but this is basically the way it works. And zip is going to basically combine any column I want into the tuples I want. So I want to take MDF and I want to combine it into, oh, you know what? Let's see, hold on a second. All right, let's see if we can use the index directly. Because remember, these values are indexes right here. I want to take these indexes with the IDF. So let's go ahead and let's see if it allows me to do that. I'll do mdf.index, comma, and I want mdf.idf. Combine this, and let's see if my dictionary works. And boom, looks great. So now I have a dictionary of the words. All right, the words and their IDF score. I'm going to now use the dictionary. I'm going to update the TF table. This is a nifty little trick in pandas tables, right? If we want to update a table like this that the words repeat over and over again. Basically, if you want to think about it for my Excel people, like a VLOOKUP, right? We're setting up a VLOOKUP situation here where we have a dictionary of values and we want the word right here to go into that dictionary of values and grab whatever value we're looking for and make a new column out of it. So this new column I'm going to make the column, call it IDF, because that's basically what I'm getting. I'm going to use the word column right here to look up, in this case it's called the map function, to map these words back to the dictionary and grab the appropriate values. Right? Bam. So these words right here, the patient was, is going to go back into this dictionary that we just created, that dictionary. Look up the words here, find the value, take that value and put it into a whole new column in TF. Go ahead and run that. Boom. I got my IDF there. I got my, and notice it's going to repeat all over the place. So if we go to myocardial for this document, it was 0.405465. And we come down here, document 1, myocardial, 0.05465. The term frequency, that changes based on document. The IDF is going to be the same across the board for each word. And from here, all that's left to do is a little math. And I have my TF-IDF. I'm so excited. And this is basically just going to be my frequency times my IDF. Go ahead and run this. Oh, I can't spell. Boom. And I got my TF-IDF score. Oh. All right, from here now, let's sort this. All right, we got our score. The higher the score, the more something's happening here, right? So I want to go ahead and do, first things first, you know what? Let's go ahead. Because I want to graph this now. So what I want to do is let me go ahead and take the indexes here and move them over. And the reason I want to do this is because I want to kind of, I want to graph this. So let's do TF dot reset index in place equals true. And basically what this does is, when I run this line, you'll now notice that the original indexes, which were here onto the left, 0s, 1, and 2, it's now become a column over here. And literally they named the column index, which I hate, but we'll let it be. And then what it does, it creates a default index for you. And the default index is always starting with 0, incrementing by 1. So each index will be unique for each one of these. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, 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 blah. All right? So from here, let's sort this. I want to sort it by my TF-IDF column. I want to put it in descending order. When you sort in Python, R, and SQL, guys, by default, sort is always ascending. So if I want to sort it in descending, I'm going to say make the ascending property false. So now it'll be descending. And I want this change to be permanent. Right, now if you look at my TF scores, my TF table. And again, because of the silly example, you'll see N is up there the most. Again, cardiac recommended. Most of these are coming from the index 2, meaning the third document. So for some reason, the third document's words are the most important for some reason. These words had the most impact on document 3. That's the interpretation here. These words had the most impact, or let me put it another way. These words suddenly showed up in document 3 versus all the other documents, right? Given all the words that are showing up throughout our entire set of corpuses and documents, these words all of a sudden showed up a lot in document 3. This is the interpretation, right? This behooves us to actually be like, all right, Why? What's going on? That's how you find these special words throughout these documents. It's one of many ways we do it, right? And again, these are just words. Remember, we still have jump into phrases using Spacy. But from here now, we can have some fun. We can go ahead and create a word cloud. I think I showed you guys how to do this before. We'll go ahead and create a word cloud from this as well. To do a word cloud with this, I'm going to create another dictionary because what I want to do is I want to graph it based on the TF-IDF score. And the word cloud object that we ran this all up here anyway, we're going to do it. You can, when you want to generate from a frequency as opposed to have the word cloud count for itself, you usually use a dictionary to do it. So I'm going to use a dictionary, use the same trick I did over here. I'll call this TF dictionary. And I will use dictionary. I will do zip. Why do I not have space? And I want to do it by the word, obviously. And I want to do it by IDF. TF-IDF. I got my dictionary. Now I'm going to go ahead and just graph this. Use the word cloud graphing tool. And again, I will go ahead and just do a square. And I will generate from frequencies. All right, and this is where I simply just put my dictionary in, and I'm ready to rock. And it'll take the words and dictionaries, do this, and from here, to make it easier on some of you, this is why I said use the PLT. This is from Matplotlib, and it might make it easier for some of you guys to show your graph. If not, do not worry, we're going to save it as well. Bilinear. Right, I'm going to go ahead and run this. Boom. Right, and here you see cardiac, and again, I think it falls in order because there's so many of our equal values, and it falls in order. And here we have our graph. You can go ahead and save this as well. Make sure you're pointing to the right, wherever you're pointed to this folder right here, this URL. When you save this command, it'll save this file just like we did last time. Underscore file. And I'll call this my med PNG image. All right, and now it's saved in my folders. If I come here to my folders, you'll see I have a med right there. Ta-da! This file you guys can go load up under, I'll set up the assignments, open up the assignment 2 for you guys. Under assignment 2, load up that image. And we're not done. Let's go ahead and now do a bar graph. And this is the one that we're gonna go back to Cgram to use this to make our life easier. And with Cgram, check out how many uses bar graph. So remember, if you remember up here, Cgram, I'm gonna call it as SNS just to make my life easier. SNS.barplot. Data is going to be my TF table, but I just want to take the top 10. You can take the top 15, top 20, top 5, again, whatever matters to you guys. I'm just going to take the top 10. On my x-axis, I'm going to put, again, if I show you the TF table right here as a guide. On my x-axis, I want to put the word column. On my y-axis, I'm going to put my TF-IDF score, right? So it's going to be a nice bar chart. But I'm going to do a little something also, because we have the documents that they're coming from. I'm going to change my bar color, in this case hue, using the index column. All right. So I'm using 3 of the columns this time. I'm going to have my word on my x-axis, my TF-ID score on my y-axis, and the color of the bar is going to be designated by the document it's coming from. I go ahead and run this. I'm not going to run this yet. I'm going to go ahead and change the title. I'll call this TF-IDF. I'm going to give it an X label. It's going to be word and or term. That should be label right there. And my Y labels will have TF-IDF. Right, that's the Y word. And when I run this, let's go ahead and run this. Bam, look at that. Look at that. I don't know if this is showing up on all your screens. I know some of you guys have problems with it, but we're going to save this as well. So you guys are going to have this on your document to save, and you're going to upload this as well. So here, check it out. Obviously, the first top 10 words, they're all the same values, so showed up. But look at the notice, the colors are different based on which document they came from. Right? The colors are different based on the document they came from. Now, this is slightly annoying right here. So what we can do is we can rotate our X label using the property called X ticks. And I'll do this rotation. You can rotation any way you want. I'm going to go ahead and do, let's do it by 45, see how that looks. Highlight this all together. Cool. All right, now that's easier to see. Right? I will go ahead and save this. Now, when you save this, the trick here is you have to run all lines 71 to 76 all together. All the lines have to be run all together when you save it. So I'm going to do PLT save figure. I'm going to name this my, I'll call it medbar chart.png. Format, oh no, you know what? Oh, cool. Is a PNG file. DPI, I think this is basically how much, the scale, detail you want. And look, I'm going to add an additional feature. And this is called BB box inches. What this does is this prevents your image from being cut off when you save it. Because with CGram, for some reason, the bar charts always get, the bottom part will always get cut off over here, right? It's very tight. So when you do bbox inches equals tight, I don't know, it's counterintuitive. It will save it. It won't let anything get cut off. So when I run, to save this, I have to highlight all this. All right, and now I come here to my med bar chart. Boom. Check that out, guys. Now we have bars. All right. And there we go. We have our, finally, we probably have a proper TF-IDF calculation. You guys can now run this code on any of your data sets. I'm going to run this on my data sets. And we have the 2 charts that I want you guys to load up. Cool? All right, excellent, guys. So this ends this part of the lecture 4. We obviously have different parts to do, but I wanted to break these lectures so they're a little more easier to digest rather than doing a 2-hour video. All right, guys. I'll see you at the next video, or I'll see you guys in the next class. All right, have a good day.